Hello students, hello friends and my dear teachers. So I welcome you all to my channel and wishing you very good morning, very good morning. So the endeavor of this channel is to make a community of chemistry loving people, and for those who are struggling in understanding of this subject. So do share the details of this channel among your family, friends and students so that we could develop a community of chemistry loving people. And in the process, we tend to see that how different domains of chemistry are attached to our daily routine lives and with the nature. So in continuation with the topic which we are studying in terms of n factor in the series of n factor. So today we are going to come up with a important topic. Already we have already discussed case 1, 2, 3. These are the three cases we have already done. So you can see onto the link shown above, and for the understanding of the first three cases you could refer to these videos. So as regard to today's topic, we are going to discuss a very important case again, where we are going to touch the topic where we are seeing the compounds or salts reacts in such a way that one element is oxidized while the other element is being reduced. So in the earlier cases, if you could refer to, in continuation with that, here would be a case where during the process of the redox reaction, one element is being oxidized, other is being reduced. Now let us see what I do mean by it. So if I talk of a case, this is a beautiful case, that if you have KClO3, and mostly you would tend to see this particular redox case in the case of decomposition reactions. So if it is heated strongly, so you can get this get changed to KCl and oxygen. So if I just simply do the balancing part here by hit and trial only, so we would be getting 2 here, and the oxygen would be 3. Now in the process, if you could see that this chlorine is in +5 oxidation state, that is perchlorate, and as a matter of fact this is in -2 oxidation state. So what you are able to see here is that this chlorine which is in +5 oxidation state happened to go to -1, and this oxygen which is in -2 happened to go to 0. So beautiful, wow. So now what you are able to see, unlike the previous cases which we done, case number 1 was one element undergoing change in oxidation state and is either reduced or oxidized. Case number 2 was uh, one element undergoes change in oxidation state but is going to different products. Case number 3, more than one element of the same compound are either oxidized or reduced. Now this is the case where within the compound one element is undergoing reduction. For that matter, this is undergoing reduction and this is undergoing oxidation. So now let us see how to find, in case we are interested to find. So if somebody asks you who is the reducing and oxidizing agent, so as a matter of fact, within the molecule one element is undergoing reduction, that means it is behaving like an oxidizing agent. Other element of the same compound is undergoing oxidation, so it is behaving like a reducing agent. So quite an interesting case. Now on balancing, what we are able to see that you have 2Cl of +5, and if somebody happened to ask you during this reaction who is the oxidizing agent and who is the reducing agent, so that is why very interesting to see here that chlorine in this is acting as an oxidizing agent. Why? Because it is changing itself into 2Cl negative, and to keep the charge balance, so there you have +10 charge, on this side you have -2 charge. So if I place 12 electrons here, so the charge got balanced, that is -2 on both sides. So here this chlorine which is in +5 oxidation state is acting as an oxidizing agent. And similarly, if I talk of oxygen here, so you could see there are how many oxygen atoms. So there are, okay, let me write 6 oxygen atoms, You could see here 2 3s are 6. So 2 3s are 6, you know very well, is what you call it as 6. So this 6 is in -2 oxidation state. And here this is not 60, 60 की power -2. It is not that. It is 6 oxygen atoms in -2 oxidation state, which goes to 0 oxidation state. Again, to simply do the charge balancing, so it is -12. Here you have 0. So to keep the charge balanced, I have to place 12 electrons here. So if I made 12 here, so this also becomes -12 equal to -12. So now you could see here that what actually has happened, what we did is this thing, that there are 6 oxygen atoms and 2 chlorine atoms. Both of these are present in 2 moles of it. Could you see it? That 2 moles of potassium chlorate is containing 2 moles of Cl positive, 5 positive and 6 moles of O2 negative. And both of these are present in 2 moles of potassium chlorate. So now if I say 2 moles of potassium chlorate during thermal decomposition is exchanging 12 moles of electron. 12 moles of electrons are exchanged among 2 moles of potassium chlorate. So this is very evident here that this 12 electrons are being lost and these 12 electrons are being gained. So now for as a understanding, we will say 1 mole of potassium chlorate, if happen to go this way, is going to exchange how many electrons? So this is going to exchange 6 moles of electrons. 6 moles of electrons are exchanged. And in this particular case, where within the same molecule something is undergoing oxidation, and within the same molecule something is undergoing oxidation, so we will say the n factor for this type of species could be found like this: number of electrons exchanged, number of moles of electrons exchanged upon number of moles of substance taken during the reaction. Of course, it has to be balanced. So during the balanced chemical equation, what we are able to see, there are 12 moles of electrons are being exchanged within the 2 moles of substance. So the n factor comes out to be 6. So for this potassium chlorate, we will say, now if you want what basically I mean by it, what do I mean by it? So I simply, if somebody asks you the potassium chlorate on thermal decomposition has n factor 6, what does it mean? It simply means during let me do it like this, that if I take simply 1 mole, if I do the thing for 1 mole, so for doing it for 1 mole, what I need to do here, I have to divide this by 2. So if, because it is written here as 2, this is 2, this is 2, this is 3. So if I divide it by 2, this becomes 1, and this also 2, this also 2. So what I am saying is potassium chlorate goes to KCl and 3 by 2 O2. So now you could see here that now you simply has 1 chlorine of +5 oxidation state within the 1 mole, and within the 1 mole you have how many oxygen atoms? You have 3 oxygen atoms of -2 oxidation state. So this chlorine, which is 1, in 1 mole it is 1, this is going to Cl negative by taking 6 electrons, and this is going to, now what is this 3 by 2 O2? So 3 by 2 into 2, that is, this simply is 3 oxygen atoms of 0 oxidation state. Could you understand this? 2 got cancelled with 2, so you have 3 oxygen atoms theoretically. So we will say it is going to lose, because here you have -6, here you have 0, so you have to place 6 electron. So what we actually, now you could see here that this chlorine and these 3 oxygen atoms are there in 1 mole of potassium chlorate. So 1 mole of potassium chlorate on thermal decomposition, if happen to go to KCl and O2, is going to exchange 6 moles of electron. So that is the n factor of potassium chloride during this reaction. So is it clear? So let me pass on to you another important, very important case shown as under. Say if I take a case of, this is a beautiful example which would help you. Let's say this is ammonium dichromate. Now if you simply heat this compound ammonium dichromate, this happen to give you Cr2O3 plus you could say nitrogen along with water. Now before I go into the details of this particular compound, let me write first the oxidation states. This is -3 and this is +6, and this happens to go to +3 and 0. This is the case. Now here you have to understand one aspect, that whenever you tend to see, this is another, so this particular topic you would get in the chapter of P block while discussing the preparation of nitrogen. So this is in your +2 syllabi, so it is quite an important one. So if you have ammonium salt, if you have any ammonium salt with some oxidizing anion, if you have some ammonium salt with oxidizing anion, so on heating it tend to lose all its hydrogen atoms as water. So this is a tip to remember. This is the tip to remember. You could go by this tip. Let me first explain what do I mean by it, so that, because our subject is a hidden subject, it is full of information, and that information could be retained with some small tricks. So what is there in this case? So what I said is, this is ammonium salt and this is a oxidizing anion. So what do I mean by oxidizing anion? Oxidizing anion is the one where the central atom is having a higher oxidation state and it has the tendency to go to the lower oxidation state, like dichromate happen to go to Cr3 positive. And similarly, if you have nitrate ion which is in +5 oxidation state, it also want to come on to the lower oxidation state, say 0. Or for that matter, if you have uh, nitrite ion, here it is in +3 oxidation state, this also would like to go to the lower oxidation states. So any anion which has the tendency, any anion which has the tendency which has the tendency any anion which has the tendency to go to lower oxidation state can be said as oxidizing anion. So I think I made my point clear. So let me give another example where you could see that the Cl negative is also anion, but it has no tendency to go to lower oxidation state, because this already is in -1 oxidation state. It cannot go to the lower oxidation state, but it could go to the higher oxidation state. So say for example Cl2 or ClO3 negative, something like that. So it can go, so it can undergo what? It can undergo oxidation rather than reduction. So this Cl negative is not a oxidizing anion. This is a reducing anion, in case it is used as an reducing agent somewhere in during some reaction. So I have made my point clear that what are oxidizing anions? Which have the tendency to go to the lower oxidation state. So what do I mean by here in this question is that ammonium salt is with dichromate. So all those hydrogen atoms which are there, just to, this is a point to remember, all those hydrogen atoms which are there in ammonium salt, this can come out as water on heating. So how many are these? So these are 8 hydrogen atoms, so I should put 4 here. So once the water goes out, you are left with only the 2 nitrogen atoms, that is N2 and Cr2O3. Everything got sorted out and got balanced. So similarly, if I want to see this particular reaction, let's say if I say ammonium nitrate, if you want to heat it, here also you could see this is in -3, this is in +5. So this again is an oxidizing anion. So all those hydrogen atoms who are there in this particular compound could come out as water. So I should write 2 moles of water because hydrogens are 4. So what you are left now with is only 2 nitrogen atoms and oxygen. So that is also a beautiful reaction to consider. in the upcoming videos you would see this is a case somewhat different than the previous cases which we have already done. So there it is in +1 oxidation state. So this is again a very beautiful example which would be coming in upcoming videos. Similarly, if you could see ammonium nitrite also, so if you heat this again, so this also is in +3 oxidation state and this is in -3, so it is also having the tendency to go to the, this again could be considered as a oxidizing anion because it can go to the lower oxidation state. So here hydrogens are 4, so all those 4 oxygens, 4 hydrogens has to come out as water as per my tip. So this you would get into. So again, this is again a beautiful question which you should focus on what type of case it is. Is it disproportionation, comproportionation, whatever it is, which we are going to discuss in upcoming videos. So let me first come on to the same point where we ended. This ammonium dichromate we are talking of. So if this goes to the 4 water and along with Cr2O3 and N2. So now in this case, if we are interested to know what is the N factor of this compound, if you happen to see this is in -3 oxidation state, this is +6 oxidation state, and this is +3 and this is 0. So here you could see how many nitrogen atoms. If I write it like this, there are 2 nitrogen atoms of -3 and they happen to go to 0 oxidation state. So that means they must have lost 6 electrons. They must have lost 6 electrons, isn't it? And similarly, if you could see, there are 2 chromium atoms of +6 oxidation state. All of those go on to chromium with 3 oxidation states. So that means this must have gained 6 electrons. So this is the electronic system I am showing it to you, that how these electrons are lost. And this is beautiful to address this type of questions where you could see that how the electrons are being exchanged. So if you could see that all of these, now this is the very interesting point, these 2 nitrogen atoms are there in 1 mole of ammonium dichromate. So this 2 chromium atom, chromium in +6 oxidation state elements are also in 1 mole of potassium ammonium dichromate. So that means if we are interested to find the N factor of ammonium dichromate in this case, N factor of ammonium dichromate in this case, this would be the number of electrons exchanged, upon number of moles taken. So number of moles taken are 1 and the number of electron exchange are 6. So we would say the N factor in this case is also 6. So here the N factor is 6. Another important example which you could come across is again a very important. I would rate this as to be very important, that the case of decomposition of potassium dichromate. So this particular question is quite an important one. I would refer to you this because this would you see in the details of this topic of potassium dichromate in the upcoming video which exclusively deals with potassium dichromate. So this on heating, if I write it like this tend to give you, this again is a beautiful question. So here again this would come in the topic of D block as well as in the P block. So in the D block, this compound is there in R slibi, and as a matter of fact, why I'm referring to it is in the P block also, that this is the production of oxygen gas. So oxygen can be formed by decomposition of this particular compound. Now in this case, if I do rub here, if I want to balance it out, just simply do it with hit and trial only. So if I place 4 here, so you have 8 potassium, so I should put 4 here. So chromiums are 8, here you have 4 chromium, so I should put 2 here. So I have balanced first potassium and chromium. Now lastly I will see the oxygen. So how many oxygens are there? There are 28 oxygens. Here you have 16 oxygens, here you have 6 oxygens, so in total you have 22. So you want to make the oxygens how many? So there are how many oxygen atoms? 28 oxygen atoms. So that means I should place 3 oxygen atoms here. So the everything got balanced. So now let me rub it, this 28, just to avoid the confusion. Now see, in this particular case, if you could see, now we are interested to know what is the n factor of this compound. If somebody happened to ask you, or for that matter, somebody happened to ask you the equivalent weight of this compound in this particular reaction. So we have to find equivalent weight is nothing but molar mass upon n factor. So now in this case, if you could break this out, that if you want to see, so if you could see here, firstly you see everything got balanced. Now we are interested to see the number of electrons exchanged. Now let us break this, and if I say you have 8 chromium of +6, let me write it here. This is +6 and this is -2. Now the beauty is, here this chromium is in +6, here chromium is in +3, this oxygen is in 0 oxidation state. Beautiful. Why is it beautiful? So this you could refer to the case 1 also, sorry, case 2 also, that there are 2 chromium atoms of +6, there are 2 chromium atoms of +6 which happen to go to 1 chromium of +4 chromium of +6 and 4 chromium with +3. If I just evaluate everything in terms of the reaction shown to you in terms of the stoichiometry, so there are 8 chromiums of +6 oxidation state, and all those 8 happen to reach to the product site like this: 4 with +6 and 4 with +3. Is it okay? So this in a way is referring to case 2. So just refer to the video, those who are new and seeing it first time. So what I could say here is, if I just break this out, so if you want to see, what I did is that there are 8 chromium of +6, so the charge here is +48, and which happen to go to chromium with these 4 +24, and this is +3, so this is +12. So now what you are seeing here is 24 plus 12 is +36. So +36 is to be made equal to +48, or rather I would say the atoms are being balanced. Now you have to place the charge balancing. So charge balancing you can do with the help of electrons. So here if you could put 12 electrons, so everything got balanced. So now if you minus 12, so this comes out to be +36 only. Now the beauty of the thing is that on the reactant side you started with 8 chromium atoms, or you can say 4 moles of this particular compound. So out of the 8 chromium atoms, 4 has shown no change in oxidation state and 4 has changed the oxidation state. So in a way this is referring to case 2, which I am repeating again and again. So another thing is, which is again very interesting, is you could see how the oxygens are behaving. So there are how many oxygen atoms? There are 28 oxygen atoms of -2. And what is their fate? How they are converting and where they are going? So they are going to, now if you could see here, there are 16 oxygen. These are the 16 oxygen atoms. 16 oxygen atoms of -2. And this 6 oxygen atoms are also of -2, and these six oxygen atoms are of 0 oxidation state. It is not 60 की power 0, it is 60 oxygen atoms with 0 oxidation state. So let me write it here, what I'm trying to say. So there are 16 oxygen atoms of -2, and there are 6 oxygen atoms of -2, and just to avoid the confusion I should write it this way only. So these are of 0 oxidation state. So this in also in a way is a case referred to the case B, that स्टार्टिंग मटेरियल में से कुछ ऑक्सीजन एटम्स इसमें जा रहे हैं, कुछ इसमें जा रहे हैं और कुछ इसमें जा रहे हैं. So this 16 we are getting from this particular compound K2 K2CrO4, and this we are getting from Cr2O3, and this we are getting from the oxygen itself. So that is again a beauty to understand. So now if you have to balance it, what basically you have on this side, you have -56 charge. On this side you have -32, -12, and this is 0. So it is -44. So minus 44 has to be equated to minus 56. So I have to place 12 electrons here. So if I place 12 electrons, what I should get here is minus 32. So this 32, 32, 12, 12. So this note, this becomes minus 56. So all of these are to be added. So you get minus 56. So this is perfectly balanced. Now let me sum up what basically I have done. So the 12 electrons are being lost by 28 oxide ions, and that 12 electrons are being gained by 8 moles of chromium 6 positive. Now this 28 oxygen atoms and 8 chromium atoms of particular oxidation state happen to, so if I show it like this, both of these are present in 4 moles of this compound. So this also is coming from this, and this also is coming from this. So what we are saying is 8 chromiums plus 6, 28 oxygen minus 2, all of them are present in 4 moles of chromium potassium dichromate. So what we are saying is, this is the viewpoint which we have referred to. So the interesting part, if somebody asks you other way around in IIT Advanced or NEET examination, they may simply ask you कि इस reaction में कितने electrons का आदान प्रदान हो रहा है, how many electrons are being exchanged. So we are able to see that within the 4 moles, the 4 moles of potassium dichromate during this reaction is exchanging 12 moles of 12, I should write 12 moles of electrons are exchanged. 12 moles of electrons are exchanged. So evidently you could see that 4 moles of potassium dichromate is exchanging 12 moles of electrons. So 1 mole of potassium dichromate then would exchange how many electrons? It would be exchanging 12 by 4, that is 3 moles of electrons are being exchanged. So the n factor for this particular species would be said as 3. So now let me do it in another unconventional way, or not, I would say, to make you feel what exactly we mean by n factor 3. So n factor 3 simply means that if you have taken 1 mole of potassium dichromate, during this process it is going to exchange 3 moles of electrons. Now to make this reaction per mole, let me do it this way, just divide it by 4. Whole of this equation should be divided by 4 so that I could get 1 mole of potassium dichromate. So if I write 1 mole of this again, so what I would get is this thing. So this is going to K2CrO4 plus 1 by 2 1 by 2 Cr2O3, and for that matter this would be 3 by 4 O2. Now simply you could see that if I talk of, now this I have made, this is I have taken 1 mole. So 1 mole of this gives me 1 mole of this potassium chromate and half mole of this. So half, now see here. Now if you could see this particular thing, that 1 mole of potassium dichromate is containing 2 chromium atoms of plus 6 oxidation state, and both of them are going to, one is going to plus 6, that is there, and another one is going to plus 3. So it is, sometimes it is a bit confusing, you should understand. So this 2 get cancelled too, so you end up with only 1 chromium. So now you could have to do the balancings. Here you have plus 12, here you have plus 9. So if I simply put 3 electrons here, so what I would get is that the charge got balanced. So this means that during this reaction, if you could see in the process, that during this 1 mole of potassium dichromate containing 2 chromium atoms of plus 6 happen to gain 3 electrons, and during the process I would say, if I consider only the chromium only, so the number of electron gains are 3 by 1 mole of potassium dichromate. And similarly, if you could see the 7 oxygen atoms, 7 oxygen atoms are of minus 2, and where they are going, 4 oxygens are of minus 2 only. And now you could see this, I have wrote 1 by 2, if you could see 1 by 2 Cr2O3. So how many oxygen do you have? So oxygen atoms would be 3 by 2 oxygen atoms, so that means 1.5. So 1.5 oxygen atoms. So I have 1.5 oxygen atoms of oxidation state -2, and for that matter 3 by 4 oxygen atoms, so 3 by 2, so 3 by 4 of this 2, so that means it is again how much? It is 1.5. So there is 1.5 oxygen atoms of zero oxidation state. Now you could see here what we basically are trying to see here is this is 7, that is -14, and this goes to, so this is -8, plus this is how much? So the how much is the charge? So if 1.5 is to be multiplied, so this is -3, and this 1.5 oxygen with zero charge. So now you have to balance the charges. So what I should do here is this is -14, this is -11. So simply if I put 3 electrons here, 3 electrons here, so this would become -14. So now the beauty is you are able to understand that 3 moles of electrons are exchanged between the 1 mole of potassium dichromate. So I think it is clear that 1 mole 1 mole of potassium dichromate during its decomposition to this particular compounds is going to exchange how many electrons? 1 mole of potassium dichromate is exchanging 3 moles of electron. So this in a way why I have picked this particular problem, because my style would be that with a given topic you are able to understand, retain the information which is categorically in your syllabus, that is in D block elements. You would going to see this particular compound in very detail. So another important case which may you refer to as of the case of potassium permanganate. So potassium manganate when heated goes to potassium, this particular compound, along with MnO2 plus oxygen. So this is again a very important case which you could refer to. Here the manganese is in +7, so here it is in +6, this is +4, this is 0. So what you are able to see, the case which we are referring to, that manganese is going from +6 +7 to +6 and +4, and the oxygen is going from -2 to 0. So oxygen as a matter of fact is also going to -2 -2. So what we are referring to here is in this case also that we are discussing the case where one element is reduced, another element is being oxidized. So I would leave you with this particular question. You should balance it out and try to solve it and evaluate what could be the n factor for this case. So I leave you with this homework, and in case you did not get it, just connect to me. I will help you out with the video of this particular compound once again. So thanks a lot. I hope you enjoyed today's session, and hope to see you in the next video where we are going to discuss another case pertaining to disproportionation and comproportionation reactions. So thanks a lot. Have a nice day.